Hi everyone, in this video I'm going to explain everything you need to know about the Unit 7 test corrections. I will go over all the questions and explanations to each of the questions, and I will show you where you can see your score on the College Board account. The correction policy is the same as for the previous tests. You have to schedule an appointment with me and explain the solutions to the problems that you missed. So question 1 is a multiple choice question. It's asking you what's going to happen to the electric and gravitational forces. And the correct answer is D. The gravitational force decreased by the factor of 4, and the electric force decreases by a factor of 4 and changes direction. The reason it's changing direction is because there are now two positive charges, whereas in the previous setting there was a positive and a negative charge, and both forces are inversely dependent on the square of the distance between the charges. Second question is about the second problem is asking about the 4 identical light bulbs, and it's asking about the 2 correct answers, and the question is all the questions are about the current. What's the current that flows into the battery and out of the battery? And the catch here, I think that some students may confuse it with the resistance. So yes, when you have series connection, you have to add up the resistances to find the equivalent resistance. However, you're not asked about resistance here, you're asked about the current. Therefore, the current in B2 and B4 is the same current, right? And B1, current in B1 is split into the two currents that one current goes through B3, the other current goes through B2 and B4. And those two currents added together will be equal to the current that goes to B1 that comes out of the battery, and the same current B1 comes out into the battery because the current doesn't get used up. It's the conservation of electric charge. Therefore, the correct answers are A and B. The current flows into the batteries I3 plus I4. That is correct. I3 and I4, which is the same as in I2. They add up together, they flow into the battery, and the current that flows out of the battery is I2 plus I3. This is I2 and this is I3. They add up, they equal to I1, and that are the two correct answers. Next question is asking about 4 neutrally charged objects, and those objects have been charged. And the elementary charge, which is shown on the y-axis, is the charge of magnitude E, right? The charge of one electron, which is 1.610 times 10 to negative 19 coulombs. So the find out what is the correct answer, you just have to look at the bar chart and see that each of the object has a whole number of electrons, whole number of the elementary charges. So in this one, object Y doesn't have a whole number, it's between 8 and 9, so it's incorrect. Only B has a whole number of electron charges, and we can see, as you can see, for all others there are incorrect charges. For the long free response, what you have is the 2 circuits with the 2 identical bulbs. One is in series, one is in parallel, and the 2 students are stating their reasonings, what bulbs, which circuit will have brighter light bulbs. And you have to answer in part A, 1, have to answer of which aspects of student 1 reasoning, if any, are correct. Explain your answer. So you have to agree with the student that each bulb gets all the current coming out of the battery because it's a series circuit. So for part A, so here's the rubric. There are 5 points. You can earn 5 points for this part A. 1 point is earned for indicating the student 1 is correct. The bulbs A and B get all the current coming out of the battery, and explaining that is because there is only one loop in the circuit. Second point is for indicating that bulbs C and D each get half the current because of the junction rule. And 1 point is earned for indicating that bulbs C and D get half the current and student 1 is incorrect in assuming that this means they must have less current than A and B. This is what a lot of students missed. So the reason that it doesn't mean that the current has to be less in C and D if they get half the current, is that these are two different circuits. So some of you got this point, but a lot of you missed on this point. So the current is not the same. Yes, C and D have a split current. However, you only have the same battery. You have the same battery in those two circuits, but you do not have same currents in those two circuits. The current is defined by the resistance of the circuit. Remember, this is the sum of the two resistances of the bulb because it's a series connection. So if the resistance is 1, so the equivalent resistance will be 1 plus 1, which is 2. So the current will be voltage, for example, 10 divided by 2. The current will be 5 amps. If here you have a parallel connection, remember, the resistance in the circle will be less than the sum of those two, right? It's the sum of the reciprocals and then flipped fraction. So if it's 1/1 plus 1/1, you have 2, which is 1/2. So equivalent resistance is less than in this circuit. And if you have the same battery, for example, 10 volts, you will get 20 amps as a current. So this current is 4 times greater than this current. So point number 4 is earned for indicating that student 2 is correct that the potential difference across bulbs C and D is the same and equal to the battery voltage. And the reason for that is because they're in parallel, or because that each bulb you can have only one loop that goes through the bulb and the battery, which is the Kirchhoff's loop rule. Okay, and the final point number 5 is given for the for giving that student 2 is incorrect. It's saying that the current is used up by bulb A before it reaches bulb B, explaining that the current moves an equal amount of charge through all the circuit elements carrying it. Part B, you can get 3 points. 1 point explains that equation 1 supports student 1 reasoning that bulbs A and B have the total amount in the current. Equation 3 supports student 1 reasoning, and equation 4 supports student 2 reasoning. So this is 3 points you can get. Part C contains of 4 points, and a lot of students missed on part C points. The reason for that a lot of students missed that the current in those two circuits will be different because of the different connection. So you cannot just state, oh, because it's parallel connection, the bulbs will be brighter. You have to explain the reasoning behind your statement, and parallel connection doesn't necessarily have a brighter light bulbs. It depends on their resistance. It depends on the voltage of the battery, right? So you have to explain why are they brighter. And in order to do this, you have to first state that the brightness of the bulb can be described by the power, by the rate of dissipating of energy that goes through the bulb. Then you have to explain, okay, how can we compare the power in two different circuits if we have different currents there, right? What can we do to compare them equally? We know they have the same resistances. So you can go different ways from here, but the easy way is to just use the relationship between the currents and then show that the brightness in the second circuit is greater than in the first circuit, but you have to use the equations and reasoning and state that the current is different because the resistances are the equivalent resistance is different for both circuits. For the second Fourier response, the short Fourier response, you are given two particles, proton and electron, and the distance between the particles is r0, and both particles are considered to be an isolated system, so there are no external forces except the force in between the particles. That's important. A lot of you, when you did the free body diagrams, you drew a lot of forces that not needed in this situation. So 2 points can be given for part A, where you have to draw the free body diagram. So the free body diagram, 1 point is earned for drawing and labeling one horizontal force on each particle that points in the direction of the other particle. And 1 point is earned for drawing horizontal forces that are of the same magnitude. That is the free body diagram. It is the same force, it is the same magnitude. So, and it's towards each other because of the opposite charge attracting. So there is no normal, there is no gravity, there is no force that is holding the electron. So just the force of electrostatic interaction between those two. Part B contains of 5 points. So it's asked what happens after they are released, when the proton and electrons are released from rest. Explain. For 1 point is earned for stating that the proton will travel toward the electron and that the electron will travel toward the proton. Perfect. Most of you did that. 2nd point is earned for stating that the electric force exerted on each particle from the other particle increases as the separation distance decreases. Unfortunately, a lot of you did not go this direction. You did not explain what happens as the distance decreases. You said, yeah, they're going forward, but then most of you said because proton's mass is greater, the acceleration is going to be less, and that's it. You didn't really go any further than that. But you're not getting point for that, unfortunately. You're getting point for these statements. So 2nd point is for stating that the force increases as the distance decreases. 3rd point is given that the acceleration increases as the distance decreases. And 4th point is given that the speed increases as the distance decreases. And 5th point is given for the consistent argument and relevant paragraph. So we have 5 points. A lot of you missed on this part here, but you can easily fix it. Next problem. This is the tricky problem. That's what I think is the trickiest problem in this test. So you have a battery, a switch, and 2 identical bulbs, B1 and B2, and they're connected in parallel, right? The switch is initially closed and current flows through the circuit. Which of the following correctly predicts how the brightness of the light bulbs changes when the switch is opened compared with the switch is closed? Okay. So obviously when the switch is open, there is no current going through B2, right? B2 is not lit, only B1 is lit. So the correct answer is D. The removal of B2 from the circuit doesn't affect the current through B1, so the brightness of B1 doesn't change. So what you want to think about is the equivalent resistance for the first situation when the switch is closed. You know that since they're in parallel, the equivalent resistance is going to be R over 2. R, where R is the resistance of each of the bulbs. So R over 2 will give us the power, right, which is current times the voltage, and or current squared times the resistance, right? So when you do that and you see that the brightness would be equal to 2V squared over R, and you can mistakenly say to yourself, oh, my brightness must increase by the factor of 2 when I open the circuit, because look, if the current is I and I do all this calculation, I find the equivalent resistance, which is R over 2. So my brightness is 2V squared over R, and when the circuit is open, the current goes through B1 only, and my brightness is going to be current times V, and current is V over R, so I get V squared over R, so it gets half of the previous power. So the catch here, this is incorrect, and the catch here that the current in the first situation is split into 2. So yes, if you find the equivalent resistance and you find the power for the first situation, it is going to be 2V squared over R. However, the current that goes through bulb 1 is half of the current that goes from the battery, right? Therefore, when the switch is open, there is the circuit changes. The resistance of the circuit changes, it increases. However, the current still stays the same current. The current through B1 be the same, because before, when the switch was closed, the current that flew through the battery was split into half. Okay, so the resistance of the circuit was low, the current was high. When the switch is opened, resistance was high, became high, the current became low, but since the resistance increased by 2, current decreased by 2, there was no change. There was no change for the current through that flew through B1. Therefore, voltage of the battery didn't change. The brightness of B1 did not change. That is the answer for the last question. Thank you for watching, and I look forward to talking to you through your corrections.